Hi, my name is Eric, and I'm excited to talk to you about how our group used nanotechnology in order to improve the mechanical properties of compostable film for uses in grocery and retail. So our group started with a major problem. The use of plastic bags in our society is ubiquitous. In fact, 1 trillion plastic bags are used worldwide every year. In Canada, the number is 2.8 billion. That's 80 bags for every person in the country. A lot of the solution that is proposed, especially in current markets, is to use reusable bags. But when you actually look into the process behind creating cotton bags, you would have to use that reusable bag over 130 times before it has the same carbon footprint as just one HDPE bag. We also have been exposed to green bin programs here around Southern Ontario, and we know that there are applications for compostable bags and that they exist. Why don't we see them in retail? Why aren't they used in grocery stores? So we wanted to really take a dive into why they are not currently seen in retail and to see what type of solutions we could come up with. We identified 3 major problems with compostable solution. The first is that they do not have the strength, which means the tensile properties, to be required to meet market conditions for Loblaws, Sobeys, and Metro. The second is that they do not have the requisite barrier properties, which means the moisture and the throughput of water through the film is a major problem to commercialization. And finally, the overall cost poses a major problem. So our group came up with a solution to use nanotechnology to create a composite film material that would allow us to increase the strength of current used compostable films so that we could use them in retail and grocery bag applications. We reached out to industry and we worked with a number of different companies. We started by reaching out to Interplast Group, which is a corporate owner of 2 other companies, Haramar and W. Ralston, one which is based out of Vaughan and the other which is based out of Brampton. And we used their existing solutions, EcoVio by BASF and Novamont Matterby, which is a thermoplastic starch, and we combined that with a biopolymer nanoparticle produced by EcoSynthetics, which is based out of Burlington, Ontario. We introduced these we created blends using a twin screw extruder, and we measured the tensile properties of the resulting blends. We did not find a significant increase in strength overall for the EcoVio, but we actually found a 20% increase with a 10% blend of EcoSphere into the Matterby product and a 72% increase in the elastic modulus. So what this means is that bags of a similar thickness can hold 20% more strength before they start to deform, and so that's a major increase in that property. With the blend that we knew we wanted to target and our previous blend, we went and worked with Polymer Specialties International, which is based out of Newmarket, Ontario, and went to their lab blow line to blow these films, which we see here. This is the regular film, unprocessed. If you feel it, it stretches relatively quickly. But if we use our film, which you can see here, it's much tougher. And you can feel that toughness because of the nanoparticles we introduced. One of the things you can see in our film, however, is the presence of aggregates that are distributed along it. And one of the issues we noticed that we came up is, well, why is this problem occurring? And so we did an analysis under the microscope, and we found that while our EcoSphere particles were deaggregating, they were not deaggregating enough because there was not enough requisite shear strength in the extruder that we were using in order to fully break them up. So upon further investigation, we found that the next improvements we would make is in processing. And this would require equipment that does not currently exist in Southern Ontario and would cost about $300,000 to produce. We have our materials that we used here. So this is the extruded resin that we used to produce our composite film. And these are the component resins that we use in our final product. Our advising prof hopes to continue research into this project. Another nanotechnology engineering group will be taking the mantle next year and improving the dispersion of the nanoparticle aggregate. So hopefully, after a couple more development cycles, we'll be able to see a film that is ready for the market. Thank you.